So this is again based on PNP. And see the structure. You have PNP and diode. You have cathode, anode. You have three junctions, but one more additional terminal. I'm going to have gate, and that gate I'm going to fix it across the layer P2. And this is the equivalent circuit for silicon controlled rectifier. You have anode, cathode, and gate. So it is just like your conventional PN junction diode, but you have some controlling terminal in the form of gate. So this gate is going to control the entire functionality of the device. So this SCR is called a silicon controlled rectifier. So you see the construction and working of the circuit diagram for SCR is given here. So it is a 4-layer 3-terminal device in which the end P layer acts as an anode and the end N layer acts as the cathode. So end P layer P1 is going to act like an anode, and the end N layer N2 is going to act like a cathode. And near the gate is attached to the terminal P layer, which is near to the cathode. So whatever P is near to the cathode, I am going to pull out a metallic wire, and I'm going to use that as my gate terminal. So PN diode is a 2-terminal device. Only cathode and anode I have. But here, in addition to the cathode and anode, I'm going to give one more terminal called gate, which is going to be present near the P2. And how I am choosing the gate? Gate is always fabricated in the P region, and that P region has to be closer to the cathode. So SCRs are SCRs are made up of only silicon. They are not made up of germanium because the leakage current in silicon is very, very less. When you reverse bias your devices based on which are made up of silicon, the reverse bias leakage current flowing through the device is very, very smaller in magnitude in silicon when we compare that to germanium. So that is the reason why all the SCRs, we don't have a device called GCR, germanium controlled rectifier. No, we have only in market SCR because in silicon only it has a unique property that the leakage current is very, very small compared to germanium. Okay, the characteristics of SCR, it is going to be exactly same. See the graph, it is going to be exactly same as your PN diode. So SCR is going to act like a switch when it is forward biased. So it is going to act like a switch. So if I am not going to apply any gate current, Ig equal to 0, the operation of SCR is similar to PN diode. So see this graph. So when I am going to give no input to the gate, it is just like your PN diode, where as you increase the voltage, the current will increase, achieve breakover, the current will still increase and then become constant. So when I am giving 0 input to the gate, or when I am not giving any input to the gate, or when I am going to leave my gate terminal open, this SCR is going to function similar to your PN diode. So when I am going to give a negative current to the gate, so the reverse bias is going to be reverse bias is going to be larger. So the breakover voltage is increased. So you can see that when you give negative voltage to the gate, so the device will take a longer voltage to achieve breakover. At the same time, if you give a positive voltage to the gate, then the breakover voltage is achieved in a very much lesser voltage. So large positive gate current, breakover will happen in a very low voltage. That the characteristics of SCR is similar to a PN junction diode. So when you give a very, very large positive current, the breakover happens instantly, and the operation is going to be similar to your ordinary PN diode. So for understanding SCR, you need to know how a PN junction diode works. So that is why we are comparing the operation of SCR with the PN diode. So if I am not giving any input to the gate, your SCR is equivalent to a PN diode. So you have breakover, you have holding current, you have holding voltage, everything is normal as in your PN diode. When I'm going to give a negative gate voltage or negative gate current, so this negative current is going to increase the reverse bias. When the reverse bias is going to be larger, the carrier, the majority carriers need more voltage to gain energy and cross the depletion region. So the breakover voltage is increased. When the gate current is positive, the reverse bias is less, thereby the majority carriers can cross the depletion region with a very less amount of voltage, so the breakover voltage is less. So when you give a very, very large positive current, then what they are saying is the breakover will happen at a very low voltage, which means that your SCR is going to work like a conventional PN junction diode. So you can clearly see here, everything lies with gate current IG. By choosing the value of IG, what I am going to provide, I can decide the operation of SCR. Okay, so the voltage at which SCR is turned on can be controlled by varying the gate current. So this gate is usually called as a controlled switch. So I can change the state of SCR to on or off by using this gate current IG. So whatever input I'm going to give to the gate, it is going to be my control voltage or controlling current. Okay, once SCR is turned on, the gate will lose its control, which means that you cannot use any input to turn off the device. So gate will have control only till SCR is turned on. So SCR is off. If you want to make it on, I can use my gate voltage. If I give positive current to my gate, SCR is changing from off state to on state. But at the same time, if I want to, once the device SCR is turned on, then the gate will not have any significance in controlling the device. So how you have to reduce how you have to turn off the device? Only by one method you have. In the PNP diode we have seen, right? So if you want to turn off the device, either you have to reduce the holding current or you have to reduce the holding voltage by keeping the gate open. So you will be supplying voltage across cathode and cathode, right? So you have to reduce that. So if you reduce that till such a way that it is below the holding current or holding voltage, the device will be automatically turning from on state to off state. So remember, gate is required for turning the device from off state to on state. But once the device is in on state, no matter how much current you give to the gate, it will not have any effect. So if I want to turn off the device from on state, only option is by lowering the current below IH. IH is called as the holding current, or lowering the voltage below VH. VH is called as holding voltage. So only by these two ways you can turn off the device. You cannot turn off the device using gate, but only you can turn on the device using the gate terminal. Please understand this SCR, and this concept in SCR is very, 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 very important.